All right, we're going on to Form B now of Chapter 3 for our 1108 students. Hopefully this will be helpful as you look at the two versions now of each of the tests. Chapter 1, there are two. Chapter 2, there are two. And this is the second for Chapter 3. Once again, this is a reflection of your study, practice, quiz-mes, mastery, and now a selection of some of that to represent what you know in the form of a test. So we're asked for number 1 to determine whether this equation represents a function. A little background. If we had y equals the square root of x, this gives us a graph that looks like this. Now, since there's more under the radical sign than just the x, it's going to look a little different than this, but that will be the general pattern. So we're asked then to determine whether or not, if we put a physical line like so, and then brought this line over the face of the graph, this is the vertical line test. Does this radical in this form of a graph pass the vertical line test? That is, does it only intersect this line in one place as it goes over it? And the answer is yes. So this is a function. Now, if it had a plus or minus in front of that, the negative value would have gone down here, and that would not pass the vertical line test because it would intersect there and there. Okay, now number 2, we have this function. So what we're asked is to substitute a 1 wherever there is an x. So 1 squared is 1, so this is 4. This is minus 2, minus 7, so that's 9. So a positive 4 and a negative 9 is a positive negative 5, letter B. All right, now for number 4, or 3 I should say, they're asking us to, given this value here, with this input into it, what do we get? Well, we do some substitution. It's 5. Now, this is our x term here. X squared plus, well, plus h. We're replacing this value for the x squared plus 7. Now, minus this value here, which is in parentheses 5x squared plus 7. Now all of this is going to be over h. I'm going to wait to put that there as I calculate this. So this will be 5 times, we're going to square this binomial, plus 7 minus just changing these signs. Now I have to distribute this through. And now I collect like terms. Well, this and this cancel out. This and this cancels out. So now what I have left is 10hx plus 5h squared. And that's all over h now. Bringing my h down here. Now I see I have a common h in each one of those. So I'm going to factor out that h on top. All over h. So these cancel out. And there is my answer. Now this is not the way I normally would see this presented, but this is the work to support our answer here. And we had one like this in our previous test. Now we might look at this in a familiar way here on a business trip, and you might pause it to read it. So traditionally we would use the distance formula. Distance equals rate times time. So there's our distance. That is equal to rate times time. But they want this expressed in a function of time. So if we bring this over to this side, and we substitute then on this side f of t, which is this, we then get 189. And when we bring this over, it becomes a negative 64t, which is letter C. This one is just tricky. So to save time, I set up each of the equations in slope-intercept. This is piecewise, where we do it in pieces, and we have these qualifiers here. So here x is greater than 2, but 2 is not included, and then we get 3 and 4. And here x is less than 2. 2 is not included, and less is 1, 0. So we're going to do some equations here. If x is 2, then y is 3. If x is 3, then y is 4. If x is 4, y is 5. And keep in mind that this is not included, but that's where we anchor it. All right, let's do this one. So we have 2 times 2 is 4, minus 3 is 1. 2 times 1 is 2, minus 3 is negative 1. And if x is 0, 2 times 0 is 0, and this is a negative 3. And again, this point is not included. So we could make our own graph, but we could see where it's used here. 2, 3. Well, over 2 up 3, but a circle. That point is not included. 3, 4. So 3, and then 4. and then 4, and then 5. So that is this line. Now for this one, it's 2, 1. So we go over 2, up 1, and again it's a circle. Then 1, negative 1. 1, negative 1, right there. And then 0, negative 3, right there. So that's this line. So the graph is C, and when we look at it, we see lots of similar graphs. Well, notice this is a solid dot. This is a solid dot. But because of our qualifiers, those dots should be hollow. And here's hollow and solid, solid and hollow. The only one that has the two hollows is letter C, where we do pieces. And interestingly, is this a function? Yes, this one's a function. This one is not a function because the x would be used twice. This is a function, this is a function. But this is the answer. In example 6, we have this function that we're asked to graph. Now, if we take away the brackets, we end up with this. So our y-intercept is a positive 2, which is right there. So this one is a non-answer. This one's a non-answer. And this one, for a positive 2, there's a hollow. So this is a non-answer. The only one left is this. And if we go over 1, up 1, over 1, up 1, then this would be, in a sense, our graph here. Like so. But I guess the use of these brackets indicate they want it this way. Number 8, they're giving us some functions, and they want us to find when x is 8. But notice out here there's some qualifiers. Here x is less than 1. So this one doesn't apply. This one, x is greater than 10. So this one doesn't apply. And this one is 8 is less than or equal to x is less than 10. This is where it applies. So basically we have y equals 8x. And we're saying that 8 is what x is. So 8 times 8 is 64. Again, part of it is to understand what they're asking, and as you do your practice in QuizMes, you develop experience in getting what would be the question. Okay, looking at number 8, here we're getting an cost function. Now, in reading this, you recall these were our fixed cost, and these were our marginal cost to produce a particular item. So they're asking us here, what is the marginal cost? Well, it's letter B. So that was an easy one, providing you knew what they were asking. Again, find the cost function. That has fixed cost of this much and marginal cost of this much. And that looks like letter D. So again, a couple of easy ones here. And for number 10, we're asked to determine the vertex of the parabola. Well, if you recall, the vertex formula is A, x plus h, or I should say x minus h, the quantity squared plus k. There we go. Now, this happens to be in the vertex formula. So we're looking for what is h and k. Well, we had said if we take our h from this formula, it has to be the opposite sign. So if it's a -4, it becomes a +4. And our k is a -5. So +4, -5. Now, if we have this, and we want to put that into this formula, notice this 4 goes into there as a 4, the -4. Okay. Now here we're asked to find the x and y intercepts. If there are no x-intercepts, state so. Well, we had mentioned earlier, make a t-chart. And in order to find the x-intercept, we say that y is 0. And we'll get to that shortly. But let's do the x-intercept. If x is 0, what is y? Or I should say the y-intercept there. So if x is 0, this is going to be a +2. Now we have to find out, using the quadratic formula, what would x be if y is 0? Now normally we have 2 of these. Again, just as a little review, we'll have a y-intercept, and we usually have 2 x-intercepts. So let's solve this. So we're using the quadratic formula, where our a is 1, b is a -2, and c is 2. So the formula -b would give us a +2 here. B squared is 4, minus 4 times a, which is 1, times c, which is 2. So we get x equals 2 plus or minus. Now this is a -8 plus 4. So under the radical, we're going to have a -4. And that's all going to be over 2. Now, from a previous lesson, we can look and see that the square root of -4 is not a real number. This is an imaginary number. So, for this, we would have, and we could do a little simplification here. This is 2. Plus or minus the square root of -4 is actually 2i divided by 2. I'll separate them. This is a complex number. So this becomes 1 minus I, and this is 1 plus I. Now, since imaginary numbers are not on the x-axis. In fact, this graph looks a little bit like this here. This graph never reaches the x-axis. There are no x-intercepts. So our answer for this is letter D. X-intercepts, none. Y-intercept, now notice they're writing it in its proper form, 0, 2, which is what we had right there. Okay, that was kind of a tricky one too. Now here they want us to graph the parabola, and this is sort of in slope-intercept form. So our B or y-intercept is a -5. So this helps us locate what we're doing. Well, this one is a -5, and this one is a -5. So these two are not in the contention here. All right, now this is 2 x squared. Now 2x squared, does that look like this one? Or does it look like letter D? What did we say happens as we put numbers like 2 and 3? And the answer is we said it got closer to the y-axis. So this one happens to be y equals x squared minus 5. This one is y equals 2x squared minus 5. So D is our answer, and the strategy behind it is you get a 2, a 3, a 4 here. These lines get closer to the y-axis. And this, of course, is your y-intercept. Now in number 13, again, they're asking for your skill in this type of parabola. When the parabola has a negative sign out in front, we said it's going to open. If this were just a negative x squared, this would open this way. Because they're asking us to compare it to this, which we had in the previous slide here. This is this graph, where again our y-intercept is 0. Here it's also 0. But now we have a +8. What did we say when that +8 is included inside the parenthesis to be squared? Does it move it to the right out here, 8 units? Or does it move it to the left, 8 units? And we said when it's inside the parenthesis, it's opposite sign. So it's going to be translated 8 units to the left, and it opens downward. Okay, I'll set up number 14 for you. So we'll set it up in stages. Here we're throwing a ball upward, and it will reach a maximum up here. And that's what they're looking for. So the maximum of a parabola is its vertex. So we're going to take this formula and eventually from the formula find the vertex. And it's a little bit tricky. So I've put this in standard form. just by distributing there a little bit and getting my 16 positive, reverse the signs. I'm going to factor out a 16 from each of these terms, and I get this. And I'm going to move my C term over here as I convert this from standard form into the vertex form. Now I know I get a 16 here. I get a T here. Now I have to take half of this, which becomes 7/4. And now I have to square my 7/4, and I'm going to get 49/16. But I'm going to add here as a negative 49/16. Well, this is a negative 16. We have to remember that this is a parabola opening downward. So when we move this out, we have a negative 16 times a negative 16. These cancel out, and this becomes a positive 49. So we now have it in our vertex form. So what is our maximum? 49. You could almost see it when you got it here, that was what it was going to be. So the maximum height of the ball, 49 feet. There are a lot of formulas here, and I'm just wondering if they're going to let you use a formula sheet for some of this, because they get a little bit tedious here. Let's look at number 15. And you might want to pause it for a moment. But the basic formula we have is profit is equal to revenue minus cost. And they give us revenue, so that will be negative 2x squared minus, or in this case, plus 56x minus now our cost, which is this, 24x plus 103. So this ends up being a negative 2x squared plus 56x minus 24x minus 103. The parenthesis actually goes there. So now we get, collecting like terms, a negative 2x squared plus 32x minus 103. So this is our function here, profit I should say, and we want to identify our A term, our B term, and our C term, because for this we're going to use the part of the vertex formula, which is x equals negative b over 2a. So x equals a negative 32 over a negative, well, it's negative 2a, so that will be a negative 2 times 2. Put the negative there, it doesn't make any difference. So anyway, this is negative 32 divided by a negative 4. That's going to give us a positive 8. So our value then for our x in here to make a profit a maximum is 8. And again, lots of formulas that we needed to execute this particular example. In example 18, this is a little bit tricky, because if we wanted to find the zeros here, this is in factored form, and we would get from this x equals 0, equal each factor to 0. So 2x equals 0, x equals 0. X plus 1 equals 0, so here x is going to equal a negative 1. And here x minus 2 equals 0, so here x equals 2. Okay, so these are our zeros. Now, this graph, believe it or not, is y equals x to the third. This is a friend of ours, where our y-intercept is 0. Right there. Now, if you were to multiply all these together, can you see that this is to the third power? So this equation is some form of x to the third. Okay. Now let's look at our y-intercepts here. We need a 0, there's 1. We need a negative 1, and we need a negative 2. So these have our zeros, okay, but is it of this nature? No, this is starting high and sort of going down. So this has the right intercepts, but this is not a choice here. Now, how about this one? This one has... No, this one doesn't have the right intercepts. Now this one does. A 1, negative 1 is 0, and a 2. And is it sort of x to the third form, that is starting low and going up? Yes, now it has another loop in it because of these other numbers that they have there. So our answer for this one is D. And we got to it by using smarts from looking at things and kind of comparing to what we know. Again, as we look at this, we notice that our y-intercept out here is negative 3. So this is 1, this is 1, this is 1. Oh, they all have negative 3, okay. But notice this is also x to the third power, and that should be a little familiar to us already. Well, going through 0 here, I was a little off. So this one, definitely not. This is starting low, going up. This one's starting high. This is starting high. So the only one that seems to fit the pattern is letter A, and that is the answer. Now, I don't know if you're allowed a graphing tool. If you had a graphing calculator, you could just put that right in there. Now, as we look at this one, and I need to bring it down, that's a little bit better. Notice our top term is negative. So, as we look at these graphs, what can we sort of pick out? Well, if we wanted to find our vertical asymptote, we'd take our denominator, equal it to 0, our vertical asymptote is 5/3. So there is 5/3 there, there, but not there, so this one's out. And I don't know if you can tell, our horizontal asymptote is y equals 0. And so this one would be out. And this one's out also because of this negative 15 up here. It would go this way, not this way. If we're positive 15, it would be this way. But again, our horizontal asymptote is really wild there. So we have a choice between this one and this one. And you might say, well, what's the difference here? Well, when the lines are this way, this is your negative 15, the negative value on top, giving you this line and this line. Here, if it were a positive 15, you would get this line and this line. So, A is our graph here. And again, I'm not sure whether they're going to ask you to graph these or just pick them out. But again, you need to remember that if it's a negative, then it fills it in this way. Positive fills it in this way. And our asymptote, horizontal asymptote, is 0. And all of these have the right, except for this one, the vertical asymptote of 5/3. And how about an easy one? Again, they're asking us what would be our vertical asymptotes. Well, just take our denominator, equal it to 0. This factors into its conjugates. So x equals 2, x equals negative 2. And that's our answer. All right, number 20. We are asked to find the cost to purify 1,000 liters of water. So the key here is, what do I put here for the x? Because x is 1,000 liters. And the answer is we put a 10. So put a 10 right there. That gives you 325 with 3 zeros divided by 610. We do the division and we end up with this. The key is, if you put in there 10,000, that would be wrong. The tricky part was they're saying it's 1,000 liters. So you only had to put in a 10 there. Do the division, and that's what you get. Well, okay, just at 40 minutes,